Hello my beautiful students, so welcome back to a new session. So I guess you are preparing well for your PU2 examination and in the meantime I guess you are also preparing for the KCET 2026. So yes, so in order to boost up your preparation, I am here with the top 30 MCQ with another 2 heavy weighted chapter, that is electrochemistry and D and F block. In the last KCET top 30 PYQ video, we discussed about the solution and chemical kinetics. Those were also heavy weighted. Today's session will be based on electrochemistry, 15 MCQ and 15 MCQ from the D and F block elements. Okay, so without further delay, let's start. So here you can see just a small analysis part so that you can understand that how many questions per year it comes from the individual chapter. So here you can see solution and chemical kinetics we already covered in one lecture. Please, if you haven't watched, please go and watch that video. Okay, and another thing you can see electrochemistry and the D and F block elements that we are going to cover now. See the number of questions every year it is coming from that. Okay, so before starting, just let me tell you, in order to spice up your preparation, to feel where actually you are standing, please enroll yourself in the ABHYAS KCET test series, where you will get 35 mock tests and you will get to see your preparation level, others preparation level, and you will get the PYQs, solved PYQs from each and every chapter in this particular series. And why you are waiting further, please enroll yourself. And this is one of the most commented test series that every year students used to request for. We used to produce so many ranks among the top 1000 in Karnataka CET exam. So without further delay, enroll yourself and see yourself in the top 1000 in the upcoming year. Okay, so let's get started with the electrochemistry. So here you can see the first question, it is related to the spontaneity. So for the spontaneity, we know the del G value must be negative, right? Gibbs free energy value must be negative. And what is the relation between the del G and E cell? So del G equals to minus NF E cell, right? So in order to make the del G negative, del G must be negative to give you a spontaneous reaction. The E value must be positive, otherwise if E cell is -1, if E cell comes -1, then negative will come positive and del G will be non-spontaneous. If E cell comes 0, then del G will come 0, it will be equilibrium, right? So for the spontaneous, we need del G to be negative and E cell value to be positive. So in accordance to that, option B is going to be the correct answer. Okay, let's proceed for the next one. Here you can see we have 4 electrodes, silver electrodes, but the solution we changed, the concentration it's changed over here, and the reduction potential value of silver is also given. Then you have to find out the reduction potential of the electrode itself. Fine. So basically what's change is going on, Ag plus is getting reduced, right? Ag plus is taking 1 electron and it is getting reduced to Ag. Okay, so we can use the Nernst equation, E cell equals to E0 cell minus 0.059 by N log of 1 by Ag plus, right? Product by reactant. So for the metal it's gonna be 1 only, so that's why concentration of Ag plus only. So for A, B, C, D we can calculate this. So let's say for the first one, for A, where the concentration is 0.01 mole, we will put here the 0.01 and we will calculate the E cell. Okay, so E0 cell is also given here, you can see. So for A, E cell is going to be, that is E0 cell 0.80 plus 0.059 divided by N value is 1 here, you can see here log 1 by 0.001. Okay, so from here I am getting 0.80 plus 0.059 into log 10 power minus 3, so that will come front. Log 10 value is 1, so from here I am getting 0.80 minus 0.059 into 3, right? So if you calculate this, your value will come almost 0.623, right? So like that I will calculate for B as well. So for B I am having 0.1 mole, so everything will be similar, right? So E cell will be 0.80 plus 0.059. Here I am going to get log 10 power minus 1 because it is 0.1 only, you can see. So log 10 power, sorry, log 0.1 or 10 power minus 1. Fine. So from here if you just calculate, the overall value will come here as 0.741. Okay. Next, if you proceed for the C, again E cell if you calculate, it will come as 0.80 plus 0.059, here log 1 by 100, right, means 10 power minus 2. So here you will get 10 power minus 2. So hence if you calculate the entire thing, your value will come as 0.682 volt. Okay, for D let's calculate. For D if I calculate, it is 1 by 1000, right? So 10 power minus 3 it will come. So similarly E of D equals to 0.80 plus 0.059 into log of 10 power minus 3, right? Okay, so here one thing that I have to rectify here, no, everything is fine I guess. Yeah, so if you calculate this entire thing, your answer will come almost 0.623 volt, right? So now you have to arrange them in order. So definitely here which one will come from? EB, right? This one is the maximum. So option B is coming first. After that you are getting EC, right? EC. After that this one E of A. After that you are getting EA. After that you are getting, it is almost equals to E of D. Okay, so in accordance to that, if you just find out, your answer is going to be something like option A, right? That is your B, C, D, then A. I guess it's clear to you. So yeah, let's proceed for the next one. Here you can see the next question, that is for Cr2O7 2 minus plus 14H plus 6 electron gives 2 Cr3 plus 7H2O. E0 value is given here. Okay, concentration of Cr2O7 2 minus is told, concentration of Cr3 plus is also told, E is also given. You have to find out the pH of the solution. Here also we are going to take the help of the Nernst equation. Let's proceed. So everything is told here, directly we can implement. E cell equals to E0 cell minus 0.059 divided by N. Here N value will come as 6. Okay, so let's write 6 here, because you can see N is the number of electron transferred. Okay, log product by reactant. So I am getting Cr3 plus whole square divided by Cr2O7 2 minus into H plus power 14. Fine. So let's see if we can come up with the pH. Let's put the value for them. E value is said as 1.067, right? E0 is said it's as 1.33. 1.33 minus 0.059 divided by 6. Cr, the value of Cr3 plus is also told over there. The value of Cr3 plus millimole, let's convert it to mole, that is 15 into 10 power minus 3. 10 power minus 3 whole square, right? 15 into 10 power minus 3 whole square divided by Cr207 value is also told, 4.5 into 10 power minus 3. 4.5 into 10 power minus 3, and here I am having H plus power 14. Okay, let's now simplify this thing. So from here what I am getting, slowly we will calculate. 1.067 equals to 1.33 minus 0.059 by 6 into log. So 15 square means 225, right? 225 into 10 power minus 6 divided by 4.5 into 10 power minus 3 into H plus power 14, right? Let's calculate further. 1.067 equals to 1.33. If you calculate this thing, it will come as 0.010, another one, then 985, right? 985 log, here you will get 4.5 and 225, you will get 50, right? So 50 into 10 power minus 3, 10 power minus 3, and here I can make it like H plus power minus 14. I can write it like this, right? So let's proceed. So from here what I can do, 1.067 equals to 1.33 minus 0.0985. From here I can just break the log term. Here log, I am getting 50 into 10 power minus 3 plus log into H plus power minus 14, right? Okay, so let me just calculate this thing for you. Log 50 into 10 power minus 3. So here I am calculating. So log 50 into 10 power minus 3. So I can break it like log 50 plus log 10 power minus 3. From here I can write log, let's say or we can do one thing, wait. We can convert it to 5 into 10, right? We can convert to 5 into 10. Hence, I am getting log 5 into 10 power minus 2. Okay, now it will be easier. So now we can do log 5 divided by 10 square, right? Because here 10 power minus 2, so if I take the sign front, it will come below. So from here what I can do is, we can even simplify log 5 minus log 10 square. So log 5 value comes almost 0.698, so we can take it as 0.7 minus here comes 2, so it will be almost like minus 1.3. Okay, so this is something like how you can break down log and you can calculate. So log 2357, this value you should remember always. Okay, so now let's put those things over here. 1.067, let's take it that side, 1.33 equals to minus 0.0985. Here I am getting the value as minus 1.30, and let's take that minus sign in front. So I will get it as minus 14 log of H plus, right? So now I can even modify it. So if you just calculate these value, this particular side, it will come as minus 0.263 equals to minus 0.0985. Here I can do minus 1.30. Minus log of H plus is pH, so plus 14 pH I can write. Right, now just simple calculation here and there you have to do. So from here, if I just do this thing, minus 0.263 divided by minus 0.0985 equals to minus 1.30 plus 14 pH. So it will come almost like 26.7. That is equals to minus 1.30 plus 14 pH, right? Let me just take it this side. Now from here, how I can simplify? 26.7 minus that side, if it goes 1.30 equals to 14 pH, right? So if you do this calculation, it will become almost like 28, that is equals to 14 pH. So from here pH I am getting 2. Okay, this is the detailed calculation, so option A is going to be the correct one. A little complicated calculation, but actually just division, multiplication and this type of things are there, not that much hectic. Okay, I guess it's clear. Simplification I guess you understood. Let's proceed for the next one. So here you can see this particular question comes, it came from the equilibrium constant. Here you can see H2 plus AgCl, it's giving Ag plus HCl. E0 cell for the cell 25 degrees Celsius is given. Equilibrium constant we have to find. So what is the reaction basically? Like E0 cell value is given here, so we can directly put the formula E0 cell equals to 0.059 divided by n into log k, right? Directly we can like implement this formula, but we have to find out the number of electron exchange, right? So H2 is getting converted to H plus. So here from here it is giving 2 electron, right? Okay, like this. Now Ag plus is taking 2 electron and it is converted to Ag. So let's multiply like that. Okay, so number of electron it's coming as 2. So let's put the value all together, 0.22 this side and that side 0.059 divided by 2 of log k. Okay, let's multiply this side, 0.22 into 2 divided by 0.06 I am writing equals to log k. So if you calculate further, your log k will come as something 7 point, your log k value will come something like 7.432. Okay, so now k value will be something like 10 power 7.43. So let me just show you a little bit how you should simplify it. So 10 power 7.43 we can just assume it to be 10 power 7.4, right? So now let's see how we should actually calculate this. So 10 power, here I am showing you 10 power 7.4 we can write as 10 power 7 plus 0.4. So from here I can get 10 power 7 into 10 power 0.2 whole square, right? The way you remember log 2357, here also to find out the decimal value, you have to remember log 0.2, 0.3, 0.5, 0.7, these values. Okay, so log 0.2, 10 power 0.2 value comes 1.58. 1.58 whole square. Okay, so now if you just proceed with this, it will come as almost 2.6 something into 10 power 7. Okay, so we will take the close by answer. You can see option A is the correct one. Okay, because we did so many simplification, right? Here we took only 7.43 and there also. Okay, so like close by answer you can take. I guess it's clear for you. Let's proceed further. Here you can see given this electrode and Fe3 plus Fe2 plus and I2 I minus is given, the equilibrium constant for the reaction taking place in galvanic cell of 2.303 RT above 2 electrode. Okay, so here I have to at first find out which one I should use in the cathode, which one I should use in the anode. So the value which is towards negative means lesser value, that should be used in the anode. So definitely this is going to be my anode and this is going to be my cathode. Right, so let's find out the E0 cell at first. So E0 cell is equals to E0 cathode minus anode, right? So cathode value is something like 0.76 minus 0.55, right? So if I proceed further, it will come as something 0.21 volt. Okay, now we can apply that formula, equilibrium constant, right? So E0 cell equals to 0.06 divided by n into log k. Here we just have to find out the k value. So let's put the value over here, 0.21 equals to 0. Here n value will come as 2 because you can see 2 electron transfer will take place. So directly we can write 0.03 log k, right? Hence log k will come as 0.3, if you divide it is 7. So from here k will come as 10 power 7. Okay, so option D is going to be the correct one. I guess it's clear to you. Let's proceed further. This is coming from the Faraday's law, right? So here you can see 1 liter solution of MgCl2 is electrolyzed completely by passing current of 1 ampere for 16 minutes 5 seconds. Okay, we will convert it to completely into second. The original concentration of MgCl2 solution, okay, original concentration we have to find. So total time at first we calculate in second. So total time is something like 16 into 60 plus 5, right? So if you calculate, this will come as 960, this is 965. So 965 second it is coming. Now let's find out Q equals to, you know, I into T. So here you can see 1 ampere current is given. How many minutes? Okay, second, that we calculated, 965 second. So from here I am getting 965 itself, 965 coulomb. Okay, now what we can do, number of moles of electron we can calculate. How? That is Q by T. Okay, so Q is 965 coulomb divided by time, Q by I we have to do. Q by F, fine. So if you proceed, 96500, okay, that is a Faraday constant. So from here I can get the number of moles of electron, coulomb per mole. Okay, from here I can get 0.01 mole, right? Okay, so now this is the number of electrons. So what is the change basically is happening here? You can see magnesium chloride, right, means Mg is in +2 oxidation state. So it will take 2 electron and it will get converted to magnesium. Okay, from here what information I am getting? 2 electron is required by 1 mole of Mg2 plus. So from there we can calculate, hence moles of MgCl2 we can calculate from here. That is number of moles of electron 0.01 divided by 2, right? So from here I am getting 0.005 mole, right? So number of moles of MgCl2 I got. So now we can calculate the molarity because they are asking the concentration. So molarity, you know, it is the number of moles of solute and that is given. We just calculated 0.05 mole divided by volume of the solution. Okay, 1 liter they have given, so I can directly write 1 liter. So from here I am getting 0.005 molar solution. Okay, 0.05 means I can write it as 5 into 10 power minus 3 molar, right? So your answer is going to be A. I guess you understood this. First you just calculate the charge, okay, then find the number of moles of electron. So number of moles of electron you can find out by using the formula like the charge that is passed through divided by the Faraday's constant, right? So number of moles of electron once you got, then just implement it in the oxidation reduction process. Mg2 plus is taking 2 electron to give you the magnesium. That is the process. So 2 electron is required by 1 magnesium, right? Hence the number of moles of magnesium by 2 electron, it is the number of moles of electron divided by 2, right? So from here I am getting 0.005. This is simply the stoichiometry calculation, right? So once you get the number of moles of MgCl2, then further you can calculate the molarity, like volume of the solution is given, number of moles of the solute you got already, and you can just end up with the calculation. I guess it's clear to you. Let's proceed further. Okay, now here you can see the next problem. By passing the electric current, NaClO3 is converted to NaClO4 according to the following equation. Okay, how many moles of NaClO4 will be formed when 3 Faraday of charge is passed through NaClO3? Okay, so let's find the oxidation state of chlorine at first. So for this case, because from here we get the data like how many electron gets transferred actually. So in NaClO3 the oxidation state of chlorine comes +5. For this case it is coming as +7, right? So net charge that flows, that we can write as, or net change that we can write in oxidation state, that is 7 minus 5, right? It is going to be 2. Okay, so now what I can do, from here I can get the information 2 moles of electron is required to convert 1 NaClO3 to 1 NaClO4. Is required to convert from 1 NaClO3 to 1 mole of NaClO4, right? From there I can get the data. If how many Faraday? They are saying 3 Faraday, right? If 3 Faraday charge is passed, so from here number of moles of NaClO4 we can get total Faraday divided by Faraday's Faraday's required per mole of electron, Faraday per mole of electron. Okay, total Faraday you can see it is 3. Okay, how many electron I need? 2 mole electron. So here I need 2 into F. Okay, so simply if you just calculate, it will come as 1.5. That's going to be the answer. Option C is the correct one. I guess you understood this. So total Faraday divided by Faraday required per mole of electron. So 1 mole required 1 Faraday, so 2 mole required 2 Faraday. So that's why 3F by 2F, FF will be cancelled out and hence you will get 1.5. I guess it's clear to you. Let's proceed further. Okay, so here comes the electrolysis. So during the electrolysis of the brine, by using inert electrode, okay, oxygen will be liberated in the anode, H2 will be liberated in the anode, Na deposits on the cathode, and Cl2 liberates in the anode. Okay, option D is going to be the correct one, because anode reaction, if you just look at, for the brine solution, this particular oxidation will take place. Here Cl minus will be converted to Cl2 and it will release 2 electron. Okay, so this reaction will be preferred, hence you will get the Cl2 over there. Okay, I guess it's clear. Let's proceed further. The resistance of 0.1 molar weak acid HA in a conductivity cell is this. Okay, the cell constant of the cell is also given, and lambda m0 of acid HA is 390 Siemens centimeter square mole inverse. Okay, so the pH you have to calculate. So for this type of question, just accumulate all the datas, whatever you are having. They gave the resistance value, they gave the cell constant value, and they gave the lambda m0, means limiting molar conductivity value as well. So from there we can actually calculate the alpha. So once we can calculate the alpha, alpha means degree of dissociation, we know H plus equals to C alpha. Okay, so our prime target is to calculate alpha. So to target alpha, we need lambda m divided by lambda m0. So lambda m we have to calculate. So to calculate lambda m further, we need lambda m equals to kappa into 1000 divided by C. So to calculate lambda m, we actually need kappa. So why we are calculating, again understand, because I have to calculate the pH. Means I need the H plus concentration. So H plus is nothing but C alpha. So to calculate C alpha, I need this alpha. To find out alpha, I need lambda m. To find out lambda m, I need kappa. Okay, like that you have to analyze. So let's proceed with the kappa. So we know kappa is basically equals to G star. G star is the cell constant divided by the R, resistance. So let's put the value here, 0.78 coulomb meter inverse divided by 2 into 10 cube. 2 into 10 cube, that is the ohm. Okay, so if you calculate from here, your answer will come something like 3.9 into 10 power minus 4 Siemens centimeter inverse, right? Okay, so I got my kappa. Next target is to calculate lambda m. So molar conductivity, let's calculate 3.9 into 10 power minus 4 Siemens centimeter inverse into 1000 centimeter cube divided by concentration, right? Concentration is given as 0.1 mole per liter. Okay, so if you calculate the entire thing, it will give you the value 3.9 Siemens centimeter square mole inverse. Okay, now what I have to do? I have to find out alpha. Alpha equals to lambda m by lambda m0. So lambda m is going to be 3.9 Siemens centimeter square mole per minus 1 mole per mole. Okay, and lambda m0 value is given 390. 390 Simon centimeter squared mole inverse. So units will be cancelled out and hence you will get 0.01 from here. That is your alpha. So from here what I have to do next? I have to find out C alpha. So let's proceed further. Concentration of H plus. So concentration of H plus I am getting C into alpha. C is given as 0.1 mole, 0.1 into alpha value I am getting 0.01. Okay, so overall I will get 0.001 molar. Okay, now let's calculate the pH. So let me do it here. So pH is basically equals to minus log of concentration of H plus, right? So let's put the value minus log of 0.001, right? Hence minus log of 10 power minus 3. From here I am getting the value 3. Option D is the correct one. I guess it's clear. Sometimes back analysis will work for you. Just from the target how you should connect the given values that you have to analyze. Okay, let's proceed further. Okay, the electrolysis of an aqueous sodium chloride solution, which of the half cell reaction occurs in the anode? Okay, so for this case anode we can take where the value is very much negative. It's like very much top in the electrochemical series, right? So in anode oxidation takes place and reducing agent they gets oxidized. So whatever is the best reducing agent, that I will take it as anode. So as you can see here, this thing is high negative value is coming, so it will be taken in the anode. Okay, let's proceed further. Conductance in a dry cell, which of the following is the electrolyte? Okay, so it's in a traditional dry cell, let me just tell you, ammonium chloride we actually used. So along with the paste of manganese dioxide, carbon powder, okay, we use this as an electrolyte. Okay, let's proceed further. Specific conductance of 0.1 molar HNO3 is given. The molar conductance you have to find out. Okay, let's see how we should proceed. So simply we will just apply the formula. Molar conductivity equals to kappa by C. Okay, so just let's proceed. Sorry. So from here kappa is given 6.3 into 10 power minus 2. 6.3 into 10 power minus 2 ohm inverse centimeter inverse. Okay, divided by here C is given 0.1 molar. Okay, so from here I can write, okay, C let's calculate at first. So C I am getting actually 0.1 mole by 1000, right? So 1000 cc. So from here I am getting 1 into 10 power minus 4 mole per cc, right? Mole per cc. Yeah. So now let's put the value here. 1 into 10 power minus 4 mole per centimeter cube. Fine. So now if you just simply calculate it, you will get something 6.3 into 10 power minus 2 plus 4, right? So 10 power minus 2 minus 4, right? So from there you can get 630, right? 630 unit will be ohm inverse centimeter square and mole inverse. Yeah, that's going to be your answer. So you can see centimeter per minus 2. Okay, because this minus 3 will go up. Okay, so your answer is going to be C. Let's proceed further. I guess it's clear to you. Let's proceed. Here you can see next question, the resistance of 0.01 molar KCl solution at 298 Kelvin is given. Okay, if the conductivity of 0.01 molar KCl solution at 298 Kelvin is given, then the cell constant we have to find out. Okay, so it's an easy one actually. G star is the cell constant, that is kappa into R, right? So directly you can put the value, that is 0.1466 into 10 power minus 3 Simon centimeter inverse into resistance also given, that is 1500 ohm. So if you just simply calculate this, it will come as 0.2199 centimeter inverse. Okay, it's a simple calculation. So your answer is going to be option A. I guess this is clear to you. It's an easy one actually, direct question. Here you can see in the next one, at a particular temperature, the ratio of molar conductance and specific conductance of 0.01 molar NaCl. It's a nice question actually. Let's target. Lambda m we know kappa into 1000 divided by C. From there they are saying that the ratio of molar conductance to specific conductance. Okay, so lambda m by kappa. So lambda m by kappa is basically equals to 1000 by C. So from here lambda m by kappa is going to be 1000 divided by concentration is also given, that is 0.01. So from here I am getting lambda m by kappa equals to 100 will go up. From here 10 power, this is 3, and from here 2, 10 power 5 I am getting, 10 power 5. Okay, so unit will be something like centimeter cube mole inverse. Okay, option A is going to be the correct one. I guess it's clear to you. Let's proceed for the next one. Okay, so commercial cell. In fuel cell, dash are used as catalyst. So for this particular case, let me tell you, the answer is C, platinum and palladium, that can be used as a catalyst. It provides the surface area. Okay, I guess it's clear to you. So 15 problems from the electrochemistry chapter, it's over here. So we will proceed with the D and F block elements. So let's start with the first question. Okay, so which one of the following pairs, both the elements does not have n-1 d power d10 ns2 configuration? So I need d10 ns2 configuration. Okay, zinc, cadmium, mercury, they are of the same line, they are in the same line, right? So they will be having d10 ns2, right? But if you just look at the copper, okay, if you just look at the copper, it is 4s1. So this pair is going to be the correct one, because zinc is d10 ns2 but copper is ns1. I guess it's clear to you. Let's proceed. Which of the following is correct with respect to melting point of the transition element? Okay, just let me tell you one thing. If you see the more number of unpaired electron, okay, more number of unpaired electron, then that will result a very strong metallic bonding and higher crystal energy, okay, crystal lattice enthalpy. Okay, so in case you are having if you can find out in which case you are having the maximum number of unpaired electron, then definitely you will get like which one is having the maximum melting point, right? So you can see vanadium and chromium. So chromium is going to be definitely high for this case. Okay, so that's gonna be the wrong one. Let's look for the B, chromium and manganese. So chromium is a D5 system, right? So for this case also, chromium, if you just look at it, is basically 3d5 4s1. Yes, and for manganese it is also 3d5 but 4s2, right? But here actually I am having the maximum number of unpaired electron. I guess I got the answer. B is going to be the correct one, because it is having the maximum number of unpaired electron, and hence let me just write, increase in the number of unpaired electron will result high metallic, and that will result high melting point. That is the thing. I guess you understood option B is the correct one. Okay, let's proceed further. Here you can see what will be the value of X if the magnetic moment mu is this. Okay, let's just solve it. Okay, let's calculate the number of n value, number of unpaired electrons. So we know the formula of mu is under root n into n plus 2. Okay, let's put the value 24 equals to n into n plus 2. I guess it's gonna be a quadratic equation. Okay, let's proceed. 24 equals to n square plus 2n. Okay, so n square plus 2n minus 24 is going to be 0. Now we have to solve it. So n square plus, let's say 4 6 are 24, right? So 6 minus 4n minus 24 equals to 0. From here I can get n square plus 6n minus 4n minus 24 equals to 0. So from here I can get n equals to 1 plus 6, and minus, if I take 4 as a common, then n plus, n plus 6 here equals to 0. From here I can take n minus 4 into n plus 6 equals to 0. So these value I will not take because the number of unpaired electron cannot be negative, right? So I can take n equals to 4. Number of unpaired electron is going to be 4. Now let's check. Iron is having two possible oxidation state. One is +2, one is +3. Now let's check in which case I am getting the 4 oxidation, like 4 unpaired electron. Let's try with the Fe2+. So Fe2+, if you proceed, the oxidation state actually it comes. In general, iron is something 3d6, 4s2, right? So for Fe2+, I will be having 3d6 configuration, right? So 3d6 means I will be having something like 1 2 3 4 5, 1 2 3 4 5 6. So here you can see 4 unpaired electron, right? Now if you just proceed with Fe3+, right? Fe3+, it will be 3d5, hence you will be n value different. You will be having n value 5. So that's not gonna be the correct one, right? N value must be 4. The number of unpaired electron must be 4. So +2 is going to be the correct one. I guess it's clear to you. You understood. Let's proceed for the next one. Okay, the only lanthanoid that is radioactive in nature. Okay, so that is basically promethium. Information based question, please remember that. Okay, so here you can see the next question. Which of the following does not represent property stated against it? Does not represent. Okay, so for this case, first one, cobalt, iron, manganese. Okay, they are in the proper series. So definitely we know as we go like in a series, the ionic size will be increasing. Okay, so that's why cobalt is the ionic size will be decreasing. So cobalt comes last, number of electron is maximum in cobalt, after that iron, after that manganese, if you come from left to right, right? So that's gonna be manganese is going to be the highest one. So this is the correct one. So number of oxidation state, this is also correct one because you know manganese you can see +7 up to +7 oxidation state. So that is also correct one. For this case, if you just look for the paramagnetic nature, yes, definitely it's gonna be the correct one because the number of unpaired electron is maximum in Fe2, then Mn2+, then Cr2+. I guess it is also fine. But look at this one. This is going to be the wrong one because for this case, the actual trend, if you just see density across the series, it basically keeps increasing, means the order should be something like Fe, then chromium, then scandium, but it is actually given reverse, right? So this is going to be the wrong one. Okay, so let's proceed for the next question. Here you can see which one of the following is correct for all the elements from scandium to copper. Okay, the lowest oxidation state shown by them is +2. So that's not going to be correct for the copper, because copper shows +1 oxidation state as well. Okay, next you can see 4s orbital is completely filled in the ground state. That is also not true, because 4s 1 is shown in copper, right? Okay, 3d orbital is not completely filled in the ground state, but for the copper it is 3d10 in the ground state itself. Okay, now the ions in +2 oxidation states are paramagnetic. I guess that's going to be the correct one. Why? Because if you see scandium 2+, that will be 3d1, right? 3d1 means 1 unpaired electron, right? And if you just look for copper 2+, that is actually 3d9. 3d9 means also 1 unpaired electron. So if the number of unpaired electron is same, then definitely it's going to be the paramagnetic in nature. So paramagnetic and the bond moment is also going to be the same one. Okay, magnetic moment value is going to be the same one. I guess you understood this, because the value is coming from the unpaired electron itself, under root n into n plus 2. Right? If the number of unpaired electron is same, then you can expect the same magnetic moment. So option D is the correct one. Let's proceed. Which of the following pairs has both the ions colored in the aqueous solution? Okay, so we have to check for the DD transition. So I have scandium 3+. So scandium 3+ is 3d0, so no chance of DD transition. Okay, let's look for Mn 2+. Mn 2+ means manganese, means 3d5. There is a beautiful chance of DD transition, and we see the color, pale pink color for the manganese 2+ salt. Okay, but scandium is not the correct option. Fine, let's proceed with the nickel 2+. For the nickel 2+, its d orbital is completely filled actually. So nickel 2+, 3d8. Okay, let's proceed for the Ti4+. Ti4+ again it's going to be 3d0. So nickel 2+ actually shows some green colored solution because of the DD transition, but Ti doesn't show again. Again Ti3+, if you look at, Ti3+ is basically 3d1. Here also possibility of showing color. This is basically Ti3+ salt usually shows violet color. Okay, or magenta color that we call. Okay, so 3d1 DD transition allowed here, here and here. Fine. Cu+, if you just look at, that is also 3d10. Okay, full filled d orbital, no chance of transition, right? So as you can see, this particular option D is going to be the correct one, because Mn2+, that also shows color, Ti3+, that also shows color. Okay, so I guess you understood this. Just let me just summarize these things here. Scandium 3+, if you just look at, it is 3d0. Okay, next if you just see for Ti4+, that is also is going to be 3d0. Another thing, if you just look at copper plus, that is also 3d10. Okay, so for these option I am having no D to D transition. So D to D transition actually will give you the color. Okay, so no color. But if you just look at that Mn2+, that is 3d5. If you look at Ti3+, that is also Ti3+, that will give you some D1, 3d1, right? This is pale pink. This is kind of violet. And if you just look at Ni2+ as well, that is also greenish. It is going to be 3d8. That is also green. Okay, so hence you can say that your correct answer is this two. Okay, I guess you understood this problem. Let's proceed further. Okay, how many moles of acidified K2Cr2O7 is required to liberate 6 mole of I2 from an aqueous solution of I-? Okay, so what actually I have to do? At first I have to write down the equation. So Cr2O7 2-, it reacts with I- to give you basically the product becomes, in acidic medium it gives Cr3 plus and I minus becomes I2. Okay, now what I have to do, I have to balance it to understand actually the stoichiometry. So if I balance it in the normal redox way, normal ion electron method, so Cr2O7 2 minus will give you Cr3 plus. So let's balance the chromium at first. Okay, now oxygen by adding 7H2 this side and hence 14H plus this side. Now what we are going to balance? We are going to balance the number of electron. Here I am having total 12 plus charge and here 6. So here I can add 6 electron. Yes, one thing is balanced, another one I minus is getting converted to I2, right? So from here I can just balance the number of iodine, and then definitely you can, I guess, understand here I have to add 2 electron to balance the charge. So in order to make the number of electrons similar, I have to multiply this equation with 3. So let's add them now. So I will get something like Cr2O7 2 minus plus 14H plus 6 electron. 6 electron will be cancelled out. Let's not write. So plus 2I minus will give you 2Cr3 plus 3I2 plus 7H2. Okay, so by looking at this and this, just you can understand 1K2Cr2O7, 1K2Cr2O7 will give me 3I2, right? 3 moles of iodine. But if I need 6 moles of iodine, definitely I need 2 mole of K2Cr2O7. 2 mole of K2Cr2O7 will give me 6 mole of I2, right? So your correct answer is going to be D. I guess it's clear. Let's proceed further. Here you can see the next question, CO2Cl2 and CuCl2 in aqueous medium. Which one is the stable? Okay, so let me just tell you here. For this particular case, CuCl2 is more stable here because, you know, whenever it comes to the oxidation state, option D is the correct one. Option D is the correct one. When it comes to the oxidation state, this is copper plus 2 oxidation state, right? So copper plus 2 oxidation state is more stable than that of the plus 1 oxidation state in the aqueous media. Okay, so why? Another reason is very high hydration enthalpy it shows in the aqueous media. That's why it is more stable than that of the Cu2Cl2. Okay, so what's the primary reason? Plus 2 oxidation state shows high enthalpy of hydration. Okay, that's why it is more stable. It's clear, I guess. Let's proceed further. A mixture of NaCl and K2Cr2O7 is heated with concentrated H2SO4. Deep red vapors are formed. Which of the following statement is true? So basically the vapor that comes, it is a reddish brown vapor, that is chromyl chloride. Okay, so let me just show you the complete reaction for it. K2Cr2O7 heated with NaCl in acidic media. This red vapor comes, and if you further react this red vapor, that is the chromyl chloride, with NaOH, you will get sodium chromate, that is of yellow color. Okay, and you will see like that sodium chromate, that particular thing, if you just further dissolve it in lead acetate, you will get the yellow precipitation with the lead chromate as well. So here you can see, look at the option at first. The vapors gives yellow solution with NaOH. Okay, that's true. The vapors contains CrO2, Cl2 only. Yes, that is also true. The vapors contains CrO2 and Cl2. So that's not going to correct, because you can see only CrO2, Cl2 you are getting. So definitely that's going to be the false option. Now last option also you can see, vapors when passed through the lead acetate, it gives yellow precipitation of the lead chromate. That is also true. I guess it's correct. Next question you can see, which of the following is an amphoteric oxide? So amphoteric oxide, here the option actually comes for the V2O5 and Cr2O3. So this one is the correct one. So amphoteric means they are neither acidic nor basic. Okay, so V2O5 and Cr2O3 is the correct option. So let's proceed. KMnO4 acts as an oxidizing agent in alkaline medium when alkaline KMnO4 is treated with Ki. Okay, means MnO4 minus is reacting with I minus in alkaline media. It actually forms MnO2 and IO3 minus iodate. But if it is in the acidic medium, it forms I2. Okay, so your correct answer is going to be option C. I guess it's okay for you. Let's proceed further, but please remember this: whenever it is reacting in the alkaline media, it will form the iodate, that is IO3 minus, and in the acidic medium it forms I2. Here you can see the next question. I have some metal that is reacting with NH4OH, gives you the precipitation. Okay, in excess precipitation, that will get dissolved, means here you can see why we are not having any precipitation further. Okay, so and that MsO4 as well, when it is reacting with H2S, it is again giving the precipitation, right? So there can be two options, either it can be zinc or aluminium. Okay, they only give this precipitation of the hydroxide, aluminium sulfate and zinc sulfate. Whenever you are giving the precipitation, like whenever it is reacting in the NH4OH, it will give you the precipitation. But let me tell you, only zinc hydroxide, it gets completely dissolved whenever further it is like excess ammonium hydroxide is given. Okay, so there can be an option that it can be zinc, the metal is zinc. And further, if you just proceed with the sulfide, the sulfide formation, that is also zinc sulfide. So Z is also going to be the Z is also going to be that zinc sulfide, ZNS. So let me just write down the reaction for a better clarification. So let me just start with ZnSO4. Let's say it is reacting with NH4OH. So basically it will form zinc hydroxide, right? ZnOH whole twice. Okay, along with that, yes, ammonium sulfate I will get NH4 whole twice SO4, right? Further, this zinc hydroxide, if you give excess NH4OH, no, then it will be completely dissolved in that, because it forms a water soluble complex, that is Zn NH3 whole 4 OH2. This complex is formed, that is the soluble one, right? And also from here, if you just react with H2S, you will get the precipitation of zinc sulfide. So that's going to be the correct option. I guess it's clear to you. Let's proceed for the next question. Here you can see the electronic configuration of gadolinium 2+. Let's find out for the gadolinium. So gadolinium is basically 64 it is given. So up to 54 we can short it out with xenon, because xenon atomic weight we know it is 54. Now 10 more we have to short it out. So we can definitely, you know, 5D will be there, 5D1. Gadolinium is a lanthanide, so in F orbital also the electron will enter. So 5D1, and then we can proceed with, we know 6S also it will be filled, and so 2 plus 1 3, so 4F7. This is going to be the configuration for the gadolinium. So for gadolinium 2+, it's going to be xenon, along with 4F7 will be there. So from here, 2 electron I can remove, so 5D1. Right? So your correct answer is going to be option B. I guess it's clear to you. Let's proceed further. Here you can see which one of this is not known. Okay, CuCl2, CuI2, CuF2 and CuBr2. Okay, CuI2 is not known because what happens, you know, if you are having Cu2 plus and I minus, actually Cu2 plus being a very strong oxidizing agent, it actually oxidizes I minus to I2. So further CuI2 doesn't form. Okay, so it forms actually Cui plus I2. Okay, I didn't balance it, just I'm showing you what actually it forms. Okay, so CuI2 is not possible. So yeah, here comes the end of the total 30 question, 15 from the electrochemistry, 15 from D and F block. So further in the next video we will again come up with 2 more very important chapters. So please, to get the video and to get such more informative video, keep commenting, like, share, subscribe, and also let me know if you are having any problem in the comment section below. Thank you so much for watching till end.